Example of factoring a binomial that happens to have perfect square terms. So what we're going to do is I'm going to kind of back it off into a trinomial and see what happens. So I can rewrite this as x squared. It's missing the x term, so I can use a few neat properties of math, the identity property and the multiplication property by 0. Adding 0 to anything doesn't change it. So I can have that middle term there. I can write it as a trinomial in this fashion. Now, if I read it like an old trinomial factoring, it would be factors of 4 that subtract up to, well, 0. So factors of 4 that subtract up to 0 are positive 2 and negative 2. So this thing is going to factor into x plus 2 and x minus 2. The problem comes from when you try to do the same technique to things that are like x squared plus 9. If you separate this out, you're going to have x squared plus 0x plus 9. And when you ask yourself what are factors of 9 that add up to 0, they don't exist. So when we have the sum of perfect squares, it is considered prime. The only one that really factors is the difference of perfect squares, x squared minus 4. X squared minus 9 would factor too, but in this case it's x squared plus 9. So we're going to consider this a prime polynomial, where this one factors rather nicely into x plus 2 and x minus 2. All right, they can get a little bit uglier, but nothing horrible. The trick really becomes taking the square root of everything you see. For instance, up here we have x squared, and down here we just have the square root of it in two different places. And the same thing with the 4, it would be the square root of 4 is 2, and then we add in the plus and the minus part, make them a conjugate pair. So if we do the same thing to this problem, we can create our two binomials that this thing is going to become. And the square root of 25 is 5, so he's going to get into the first positions. The square root of x to the 4th is x squared. And then the square root of 4 and y squared would be 2y. So we get all the pieces together, and we just make sure one is positive and the other one is negative, a conjugate pair. So this would be the factors of 25x to the 4th minus 4y squared. And it breaks up rather nice and easy. Where the perfect cube binomial factors into, I just want to multiply these two things together and see what happens. So if we start off, we're going to get 2x times 4x squared, that'll be 8x cubed. 2x times a positive 6x, that'll give us a positive 12x squared. And then 2x times this positive 9 way down here, it'll give us positive 18x. A little review of multiplying polynomials. And then we're going to distribute the negative 3, that'll give us a negative 12x squared. I'll match it up with the correct variable. Negative 3 times positive 6x is negative 18x. And then negative 3 times this positive 9 way down here, that'll give us negative 27. So when we add these two together, what we're going to get out of it is 8x cubed. These are going to cancel, positive 12x, negative 12x, and here we have positive 18 and negative 18. So we're left with a binomial, and the numbers in them and variables are all perfect cubes. We got this 8, we got this x cubed, and we got 27. 2 cubed, x cubed, and 3 cubed. So the pattern involved in factoring it is there's going to be a binomial piece and a trinomial piece. And the way it breaks up is you're going to take the cube root of everything, that'll give you 2x minus 3, and then there's a pattern. The book will use a formula, but I'd rather look at the pattern. I know that the next term is going to be a trinomial, and 4x squared is this first term squared, 2x times 2x, so that gives you the 4x squared. Up here, the next term is plus 6x. Well, I can get that by taking these two numbers and multiplying together, or the two terms. I just need to change the sign, so it becomes a positive 6x. And then lastly, I have this positive 9. Well, that's just negative 3 squared, so you get plus 9. So it becomes a cube root, the original, get rid of all the perfect cubes, and then take the first term and square it, take the two terms and multiply them together, change the sign, and then take the last term and square it. Okay, so let's see how this works on something like x cubed plus 8. a simple one. Okay, x cubed plus 8. So we're going to cube root. This is a perfect binomial cubed. And in this case, unlike the square one, this can be plus or minus, where the square one has to be the difference. This one can be the sum or difference. All right, so we're going to take the cube root of everything. So the cube root of x is x. I'm sorry, the cube root of x cubed is x. And then the cube root of 8 is 2. So that gives us this gives us the binomial term. Now we just need the trinomial. So you start off with the first term and you say, well, square it. Well, that becomes x squared. Then you take the two terms and you multiply them together, and that gives you 2 times x. Here it's positive. Here we're going to make it negative. And then the last thing is, take the second term and square it. Positive 2 squared is going to be positive 4. That last number will always be positive. So x cubed plus 8 factors into x plus 2 times x squared minus 2x plus 4. If you have something like 27 x to the 6 minus 125. It's not hard to factor, it's just you have to do a few more steps than the perfect square one. Alright, so you break it apart into the perfect cube root binomial. 27's cube root is 3. X to the 6 cube root is x squared. It would be x squared times x squared times x squared. Minus, and the cube root of 125 is just 5. And then you just go with the pattern. It's going to be 3x squared, and you're going to square the whole thing. So that becomes 9x to the 4th. And then you multiply the two of them together. So that'll give you 15x squared. But we need to change the sign from minus to plus. And then lastly, we're going to take negative 5 and square it, and that'll give us a positive 25. And there we have factored the perfect cube. The difference and the sum of perfect cubes works exactly the same. Kind of neat.